Welcome, everybody. Thanks for coming. Thanks for joining us in this product presentation. We are going to talk about LARA system. Just for you to know, this session is going to be recorded by our team of marketing. What is LARA system? LARA system is the PA you've got here in the venue, front, left, and right, and the PA you are seeing on your screen. It has been a long process. It's been almost 3 years to arrive here, and I will try to explain a little bit in more detail all the features and all the functionalities of the new system. But before that, I would like to remember where are we coming from. We are coming from Aero Series 2 and UX Series, talking about Turing systems. What we've been doing in the last years with this new project is to improve what we already had, which is a very, very good starting point. Our strongest points with Aero have been reliability, self-powering the systems, the way we design, we manufacture the waveguides and the horns of the systems, and the DASnet control software. That has been our starting point for this project. Once we have in mind the origins, next step that we talk and we had discussions at the factory with our salespeople, with technicians is, okay, we're working in a new system. How it has to be this system? Obviously, for us, the system had to be self-powered. For us, it's a philosophy. Is something which is in our DNA as a audio manufacturer because it has many, many benefits. Among them, reliability, the fact that all the amplifiers are especially designed to match the transducers that we're using in them or together with them. In terms of consistency, cross-rental, you can rent a system, and it sounds the same no matter the place where you are in the world. So these factors are really important for us, and obviously, we just wanted to continue with this line, creating self-power systems. Next feature, and this is completely new for us, it had to be cardioid. Why cardioid? Because actually today, noise pollution in neighborhoods, surroundings of festivals or concerts, it's more and more a key factor for the promoters, okay? That plays one important factor, and the other important factor, obviously, is that here on stage, we are having less noise and less pollution, so making life easier for basically musicians and technicians. In terms of efficiency or cost, having a subwoofer that's cardioid by itself reduces the amount of subs needed to create a cardioid with non-pure cardioid subwoofers, okay? Another point on the wish list that we wanted is that the system had to be symmetric. Symmetric to assure an even horizontal coverage, as much as compact as it could be for both subwoofer and top. And let's say these were the 4 or 5 key factors we wanted for the system. Let's see now which are the main features that we are including in the PA. Obviously, we talk about active system, self-power system. It had to include a brain. The brain of the system is always a powerful DSP. We need a powerful brain to power all the capabilities that we want. Remote control. We talk about DASnet. DASnet runs over RS-485 protocol. Now it's time to move to IP. We need control over IP. That's a new added feature we are including in this system. Rigging. Again, we need to make the rigging even faster and easier than before. So our choice has been selecting a 3-point system rigging. 2 points at the front, 1 point at the back. One other added important feature. We wanted to have one system with a tremendous dynamic headroom, super high SPL and tremendous dynamic headroom, which in the end means that we are going to have a system with a very, very low distortion. In the end, it's just related to quality, to perceived audio quality. The horizontal pattern of the cardioid control is one of the key features, okay, to control the audio that's going side to side or even at the back of the system. One very important features. Let's see how this new system has the transducers. Transducer arrangement. Here we see a top view of a cut cabinet in the middle, and you see the disposition of the transducers. We do have 2 front firing 12-inch woofers for the low frequency section, the ones that are in red on the screen. We do have, and this is new, 2 rear firing 8-inch speakers. For what purpose? Doing the cardioid functionality together with the 12-inch speakers. So the low frequency way or channel in this cabinet is composed by 2 different types of speakers, the 2 12s at the front and the 2 8s at the back. MF and HF. It's composed by 2 8-inch speakers and 2 3-inch voice coil diameter compression drivers coupled to a waveguide horn device. And the fact here that is important is that the mid-range speakers are inside, are part of the HF horn. So we want to just have a perfect control on the dispersion in the horizontal and vertical plane for the system. Talking about the sub, same idea. Top unit is a cardioid system, subwoofer has to be a cardio system as well. So in this case, we do have 3 speakers in the box. Again, here is the layout of the system. 2 18-inch speakers firing to the front, and there's 1 18-inch speaker which is radiating to the back of the system. The distance between the sources is the adequate one to achieve the polar pattern that we want, the perfect cardioid and the cancellation at the back of the system. As I said at the beginning, this has been a real challenging project for us. Almost 3 years of work, many, many disciplines involved. And one of the most important ones is the engineering department that we have at DAS, just dedicated to our transducers. So for this project, we just designed all the transducers are new and specifically designed to match the needs of any of the channels on any of the ways of the system. We do have new 12-inch speakers, the woofers for the LARA, completely new, powerful magnet assembly, very, very similar to the magnet structure that we're using in the 18-inch speakers. Then, very important for you to know, 8-inch speakers, the ones that go at the back use a new custom suspensions. And the mid-range speakers is totally new as well, the 8MXN, and they include a very, very big magnet. It's almost a compression driver with a comb paper. Compression drivers, we're using 2 3-inch voice coil compression drivers with ferrofluid in them just to linearize the frequency response and improve the distortion level. Talking about the subwoofer, in this case, we are using our existing 18 UXN the subwoofer, or the speaker, sorry, that we are using for our existing UX-1818As. This is a new component that we developed like 5 years ago, more or less, and it's perfect for this application in the LARA sub. One of the key factors, one of the key pieces always for linear array system is the waveguide. We need to control from front to back the coherence between the audio sources. This is achieved with the waveguide. On the screen, you've got a picture of the waveguide where we will couple the compression drivers and the MF 8-inch speakers. Since years ago, we are using simulation softwares to develop this type of pieces. We're using, in this case, console software. And here, just to give you an example, this is half of a waveguide. And this is the simulating software. And this is the type of results that we get from it. So we can design the piece virtually. We can have a prediction of the isophasic wavefront. This is at 7 kilohertz. And the important thing for you to know, and just the measures that I want to understand it, is that we have these simulations and compare with reality. And the fact is that reality matches simulations in the majority of the cases. So the important thing for you to know is that our simulations are perfectly matched with the reality. On the screen, on the left side, we've got the vertical plot, the vertical coverage of the high-frequency section of a LARA waveguide. But this is a simulation on the left side. Right side is the real measurement on the anechoic chamber. So this is what we want. We want to simulate, but to have an accurate result that we can trust on. So at the time, we develop the horns and the waveguides. Amplification. This is another of the key factors of the system. We are powering both top and subwoofer with power soft amplifiers. In the case of the LARA system, we are using an 8-channel amplifier of 6 kilowatts. And in the case of the LARA sub, we are using a 6-channel amplifier of total 3,600 watt. What is the disposition? How we power each of the transducers? Well, here we can see it. Already said that 8 channels of amplification. Channels 1 and 2 are bridge to power one of the 12-inch speakers. Channels 3 and 4 are doing the same, powering the other 12-inch speaker. The rear 8s are just depending on one amplifier channel, channel number 5. The mids are powered by channel number 6, and the compression drivers are used in bridge mode of channels 7 and 8. And this is one of the advantages of the system. We need a lot of dynamic headroom. We need a lot of peak voltage for the HF, for the high-frequency devices. If I'm not mistaken, I think we are about delivering to the compression drivers maximum voltage is around 155 volts, just to give you an idea. In the case of the subwoofer, what we have is 6 channels, and we are using pairs of 2 on bridge mode. So channels 1 and 2, channels 3 and 4, channels 5 and 6, they do by pairs every single 18-inch speaker. Power factor correction. This is a trademark of PowerSoft, and in the end, means ultra-low consumption of the systems, very, very low distortion in terms of voltage, and the main fact is that no matter the voltage of the mains, the amplifier is always able to deliver maximum output. As a consequence, we've got a system with less than 4 amperes consumption at 230 volts. LARA is consuming 3.75 amperes at 230 volts. And LARA sub is consuming 7.5 amperes at 230 volts, okay? Double current consumption for 115 volt. High performance DSP. We talked about at the beginning about having a very powerful brain inside the systems. And this is everything. For an active speaker as this one, having this type of device is everything. One DSP working at 96 kilohertz per cabinet, FIR processing, AD/DA converters with more than 120 dB dynamic range, 32-bit microcontroller, an Ethernet control with an internal switch for easy daisy chain between cabinets. To have what? To have a great capacity of processing, controlling, optimizing, and monitoring the systems. Each single box has this capability of processing. Besides EQing, besides crossovers, one of the most important things is assuring for you, the end users, reliability. In the end, this is your tool to work every day, and we need to be able to assure long component life, okay? Every active speaker, every LARA system includes RMS, peak, and excursion limiters to protect our transducers. Again, as I said at the beginning, it's a perfect match between the amplifier, the DSP, and the transducers, all together combined as a perfect team. FIR filters included in the systems. For the ones that are familiar with us products, we've been doing this for years in Vantex series, in some of the event series, and in Aero Series 2, Aero 20, and Aero 40, or they're using FIR processing. In this case, again, obviously, we are using FIR processing for the LARA top systems. In the end, the FIR processing, one of the key features besides the time alignment and the phase response is that we got a very defined and clear sound coming out from the source, from the LARA system. Phase response is flat from 200 hertz till 15 kilohertz, 16 kilohertz. And this is a tremendous advantage in terms of audio quality, because this means basically that all the frequencies in that range arrive to our ears at the same time. Another new technology developed for this project is the self-positioning technology. When connected to the software, the user is not going, there's no need of taking notes or checking the IDs of the systems, because they already will know in which position of the array they are going to be allocated, okay? We are using the NFC technology to get this new feature. This new technology, the NFC, permits the systems, the cabinets, talking one to each other so they know where they are placed. The most advanced features of the systems are going to be controlled or adjusted using the control monitoring software. But basic parameters always could be set up using the control panel, which it's allocated at the rear of the system in the amplifier panel, okay? For instance, health check option. In this case, when systems have done an event or a festival, and you are bringing them back to the warehouse, the guys at the warehouse just plugging in the power and going at the back to the control panel and selecting the option, they can already check the state of all the transducers and the amplifiers with no need of a PC or any other device or measurement device. The cabinet, it's including a microphone, so it will make a sweep, and it will just test it, all the components, all the state of the system. With the digital signal processing, remember, we've talked about the fire processing, about the limiters, about the self-positioning. We talk about monitoring temperature, monitoring load per channel, monitoring the headroom available, very important, and also having the capability of including EQ, okay, on the systems. So there's a bunch of new added possibilities with this very high power DSP that we include in the systems. For sure, one of the technologies we wanted to include is the same, already available for Aero 20s and Aero 40s. With this technology, basically, we control the vertical radiation pattern of the whole array. We achieve a uniformity on the frequency response front to back. We can control the SPL over the distance. I mean, we can achieve that you guys listen the system at the same volume, at the same level that the people over there and the people over there. So very, very important technology, and we will display later here. We'll show it for the new system. 3 years developing LARA system, 3 years developing the new ALMA software. ALMA has been a huge project for us. We've got software team at the factory dedicated to this new platform, which basically permits real-time control and monitoring. It works and it's compatible with existing systems over RS-485, but also, and this is a new feature, over IP. Valid for Mac and Windows, and optimized for touch screen. And there is something which is also very important. ALMA has to be the environment where we include all our electronics. It's not only active line array systems, but it's also valid, and it's including also integral amplifiers and the DSPs. So every single electronic device is going to be included here in the software. Here on the screen, we've got some of the functionalities that you can have. EQ control, show and config mode. The end user can lock certain parameters. If you don't want that nobody touches, for instance, the gain or touches the EQ, you can lock that feature in show mode. There's a notification center, obviously, giving you messages. If something happens, if there's a fault in the load of a certain cabinet, that would appear in the notification center. We've got master controls, which means that for a certain arrangement of speakers, you can control the gain, you can do mute, you can do solo, you can change the delay. So of the whole cluster as a group. We've got a very powerful link manager to link parameters between different audio sources. Day and night mode, this is something new as well. The same technology, obviously, DASnet was included in this feature. ALMA is including it as well. We can just launch the FIR filtering for the LARA systems of the Aero 20s, Aero 40s to get this vertical coverage optimization. And we've got many, many other different windows. I encourage you to download the software, which is available on our website, and just try it with your systems. Efficient distribution. For a system like this, we need different options of cabling, of signal. In this case, we are including Dante audio in the racks with the power distribution as well, ASEBU signal or analog signal. Then we've got, in terms of power, we can use the existing cabling with power cons or SOCAPEX distribution. This is a view of the signal distribution panel, okay? The important thing here, besides the type of audio, the format, is that we are using the same cabling we already been using for Aero 20s and Aero 40s. So the hybrid cabling using power and then audio and monitoring data is the same, very the same. The power distribution, we've got this new power panel where we have 6 output circuits with PowerCon or 1 SOCAPEX, including these 6 same circuits. In this case here, we've got 12 pieces aside, and there's 1 SOCAPEX going up to the PA with the 6 circuits. Each circuit is powering 2 systems. One of the premises was also to have a new rigging system. Rigging system we are including right now is a 3-piece rigging system. We've called it fast set display rigging system because it's very easy for the user to change display angles between the cabinets while they are stuck on the dollies. Okay, here you've got a picture of the 3-point rigging system. We add an additional rear locking pin to secure display angle between the boxes, kind of on a stack, and avoid them collapsing one against each other when they are flown. Display angles vary from 0 to 7 in steps of 1 degree. We do have only one reference of flying bumper. There's one unique flying bumper for the subwoofer on the top cabinet. I haven't said this, but subwoofers are including rigging hardware by default. So the rigging bumper is the same. Permits hanging maximum up to 16 units of LARA sub, depending on the pinpoint on the bar on top, and up to 28 units of the LARA system. The rigging bumper permits doing down tilt or up tilt. If you reverse the bar on top, you can do up tilt of the array. Each rigging bumper is including an accessory. It's a small piece that is attached to the bottom box to do a pullback in case you need a more, let's say, vertical angle of the system. We have developed a bunch of accessories to make your life easier in terms of transportation and in terms of use. For stacking, we already can use the dolly, the transportation dolly of the LARA with an stacking kit, as you are seeing in the screen. There's another way of stacking the system. You can stack the LARA system on top of the subwoofer. This is a specific piece that's attached to the back of the LARA system that goes on top of the sub and permits doing a stack, as you are seeing here. Rotation. We can control the horizontal angle of the entire cluster with a delta plate. Transport efficiencies. This is very important. Consumption is very important in terms of, saving costs for whatever they use, but also transportation needs to be really efficient in terms of trucking. So basically, what we want is just to have systems that minimize this, minimize or permit having more room in the tracks for other parts. So here's the layout of different tracks. For a track of 90 inches width, we will combine the systems as they are on top of the screen. And for a more conventional track, between 90 to 99 inches width, we will basically place two dollies together in both cases, in the LARA sub and in the case of LARA tops. To facilitate, to make it easy, the brigging bumper can be transported on top of the first LARA of the four pieces that's put on the dolly. We can just disassemble the big bar and turn it 90 degrees and left on top of the system, of the first unit. So you don't need to remove the bumper from the cabinets. You can keep it there for your transportation. We also have another accessory. A top hat is a wooden piece that goes on top and also is compatible with the cover. So you can just have another flat surface to double stack whatever is needed. Relevant data. Well, here shown capture of smart life of one LARA system, frequency response, flat frequency response, going down to 55 hertz. This is a very, very unique feature that makes the system behave as a big system. It's going down to 55 hertz, but with these new 12-inch speakers, with long displacement capability and low distortion, the system is really powerful on the low end. On the other extreme, going up to 16, 17 kilohertz. LARA sub. In this case, we do have, remember we have three different low-pass filter options. We have 63, 80, and 100. So it's depending on your taste, on what you want. You can cut the sub at 80 if you want more punch sound. If you want to sound it more like a sub bass, you low cut the system at 63. In this case, the graph shows the response of the system with the low-pass filter at 63 hertz. Me and other colleagues working at the factory, we are running the system this way. Subwoofers with a low cut at 63 and tops with a high pass at 63 hertz. Horizontal coverage. Tremendous consistency over the 100 degrees that it has in the horizontal plane. The system keeps the tonal balance off axis. You move off axis and the frequency response is dropping in level, but in parallel or in reference with the fundamental response. And we are getting a control down to 100 hertz, more or less, 100 and 120 hertz. So this is a very unique feature that we are achieving with the 100-degree horizontal dispersion coverage. We do have, in the case, also, as you see in the polar plot, we do have also a cardioid behavior, eliminating the energy at the back of the box. For the subwoofer, we've got a cardioid pattern control, so the radiation is optimized to be cardioid between 40 and 80 hertz. And in both cases, we are getting a very similar rear attenuation in terms of dB. In the case of LARA, 15 dB less when you compare the pressure between front to back, front to rear, between 63 and 200 hertz. In the case of LARA sub, 14 dBs of reduction between 40 and 80 hertz. So it's a huge step in terms of benefits for cleaning the stage. At the beginning, we talk about SPL, dynamic headroom, and low distortion. This is unique. This is 146 dBs measured, real measured, nothing calculated. This is real, pure real. Measurement under linear conditions with no distortion, 146 dB peak SPL. In the case of the sub, 140 dB. Okay, so we are talking about tremendous SPLs in both cases. Okay, and for me, this was it. Now, I just encourage you to move around and to listen to the equipment at different positions, different points. And again, thanks for coming. Thanks for joining us. And it's been my pleasure. Bye-bye.